if you see in this question, the question says that there is a rectangular plate of mass capital M, means this is the rectangular plate of mass capital M, which has the dimensions A cross B, means this is A and this is B. Means the length is L and the breadth is B. The plate is held in a horizontal position. This is a very important line. The plate is held in a horizontal position, means like in horizontal it has been held, which means also we can think if this is a plate, of course, because mg will act in the downward direction on the center of mass, so this downward mg will try to rotate this plate in this direction. So it is held in this position. Now let us see how is it held in this position. So further the question is saying that it is held in horizontal position by striking n small balls, each of mass m, per unit area per unit time. So how is it held? By striking some balls. Of course, when we will strike some balls, we can also understand it logically that we can held this plate, and whatever information is given in the question, we should keep it in mind that the balls are striked in this shaded region. And according to the question, it is saying that in 1 meter squared area, let us take in 1 second. So in 1 second, in 1 meter squared area, we are striking n number of balls. Okay, so this n small balls, each of mass m, okay, so the mass is m, they are striking per unit area per unit time. So means in 1 meter square area, in 1 second, n number of balls collide. And this is the reason where balls are actually colliding. And the area of this, of course, this is like half of the total area. So area in which the balls are colliding is a into b by 2. The total area is ab and a into b by 2 is the required area. So in this meter square area, what will be the number of balls which will collide in 1 second? That will be n into ab by 2. So this is simple unitary method. So the total number of balls colliding will become nab by 2. Number of balls is striking the area in 1 second. Okay, so this is the capital N. Now if we see the change in momentum due to one ball. So when one ball will collide, let us suppose this is the kind of horizontal plate. One ball comes from downward direction and it collides. So it will hit it like this and then it will go back in the direction, means E is equal to 1 because this is elastic collision. So if it strikes it by V, then it will return with the speed EV, which will be nothing but V. Means it strikes at with some velocity v and then returns back with some velocity v itself. So the change in momentum will be mv minus mv. So delta p becomes 2 times of mv. And this is due to one ball and the total number of balls striking is this. So change in momentum due to all will be equal to 2 mv multiplied by nab by 2. So this gives us mv nab. Now we have to calculate force, and force is nothing but dp by dt, and we are talking about in 1 second. Everything we are taking for 1 second, so this dt is like nothing but 1, and in that the change in momentum is mvnab. Means this is the force which is actually balancing out the mg, which is resulting in the fact that this is being held, and this is the hinge by which it has been held. Okay, so now let us check what we have to do further. Now if you try to understand the situation out here, we have mg acting here, and this is being balanced by some F force. Now this F will certainly being applied on the center of mass of the shaded region. Okay, so this is the center of mass of the shaded region, and mg will be applied to the center of mass of this rectangular plate. So this is the distance is b by 2, and this distance is what? So the distance of mg is b by 2 from this hinge point, and the distance of this point we can calculate since this entire distance is b. So if we subtract this distance, which is b by 2, we will get the distance of this F force from the hinge. So that will be b minus b by 2, that is going to be b minus b by 4. This distance will be b by 4, sorry. So this will give you 3b by 4. So here we have the distances of both the force from the hinge point. Now what we will apply is that tau about hinge is 0. Torque about this hinge is 0 because this plate has been held in the horizontal position. So which means both of these forces are actually balancing out each other. Means the torque are equal in magnitude, opposite in direction. So what we will do is like this F force. This F will try to rotate it in anti-clockwise direction, which means it is dot. So this F multiplied by this distance, which is 3b by 4, plus this mg will rotate it in clockwise direction. So this is cross, and capital M, this is capital M because this is the mass of this plate, which was capital M. Capital M into g, and this is b by 2. So we will simply do this F. Both of them are equal. So this b cancels out and this cancels out like this. So 3f is equal to 2 multiplied by m into g is 10. 3 multiplied by f. F is mv. NAB is equal to 2 capital M into 10. So this 3, this is small m. Now we will plug in all the values which are already given in the question. So from here we can see that small n is 100, capital M is 3 kg, small m is 0.01 kg, B is 2, A is 1 and G is 10. So we will plug all these values out there and we will simply get the value of V which we want. We need to find the velocity V. After simplifying it, you will see that this V is equal to 10 meters per second. This is the answer. Thank you so much.